Hello guys, in this video I'm going to show you how to find the gradient, the divergence and the curl of a function f. So this symbol, the inverse delta, is called nabla and it's a vector, which means partial derivative on the x-axis, then partial derivative on the y-axis is the second component, and the last component is partial derivative on the y-axis. So if we want to find the grad of this function, okay, what we have to do is write a vector whose first component will be the partial derivative of this function as a function of x. So we're going to take this function and derive it as a function of x. This means that y and z will be assumed constants. So for the first component, we'll have 4 times x y square. There's no x variable here, so this goes away, and minus x will be minus 1. For the second component, we'll need the derivative of this function as a function of y. So this first part will be 4x squared y plus z, and there is no y in the last part. Okay, so for the last component, we'll need to derive the function as a function of z, so nothing from here, we'll have a y from there, and nothing from there. So here's y. So this is the gradient of function f. Now, for the divergence and the curl, the function f needs to be a vector. So we want to find the divergence of f, okay, where f is going to be a vector with 3 components, let's say x squared and y squared, y squared and z squared, and x squared and z squared. So the divergence of function f is nabla dot product f. Now for convenience, let's call these components P, Q, and R. So the divergence then is going to be nabla is del x, del y, del z, and f is P, Q, R. So we need to solve for del P del x, so P del x plus del Q del y plus del R del z. So the first part, del P del x, will be the derivative of P over x, so that's going to be 2 times x, plus the partial derivative of Q over y is going to be 2 times y, and the partial derivative of R over z is going to be 2 times z. So the divergence of f is a number. Okay, moving now to the curl of this vector f. It's going to be the external product of, so curl of vector f is going to be the external product of nabla and vector f. So we already know that nabla means this quantity over here, and vector f is defined here. So this will be equal to the determinant of I, which is the unit vector on the x-axis, j, the unit vector on the y-axis, and k, the unit vector on the z-axis. And here we have nabla, so del x, del y, del z, and in the last row we have the components of the f vector, the p, q, and r. So we need to develop this determinant. So we'll have unit vector I times the determinant over here. So del r, del y, I'm going to write it ry minus del q, del z. So q, z. On the j component, we'll have del p, del z. So p, z minus del r, del x, rx. And on the k component, we'll have del q, del x, so qx, minus del p, del y, so pi. Okay. So ry will be 0, minus qz is 2z. Okay. pz is 0, minus rx is 2x, and on the last component, qx is 0, minus py is 2y. We can write this a bit nicer as minus 2z minus 2x and minus 2y, and I remind you that this is a vector.